Hello, my name is Valery Khirin. I would like to present you our final Java project in algorithmic programming in Java course. The program was developed by Yarden Yerushalmi and Valery Khirin. In our project, we built 3D maze game called Moses. The goal of the game is helping Moses to get to the promised land by moving the character through the maze until it gets to its goal. In order to build the maze, we use two different building algorithms, simple maze and growing tree generators. The simple maze builds the maze randomly, which means random start and goal positions and random walls. It also assures that there is a path from start to goal position. The growing tree algorithm works different. It's based on an empty list of cells. We add one random cell to the list and call it cell X. The algorithm chooses the last cell that was pushed to the list. In our case, it's cell X. It takes X random neighbor and pushes it to the list after X and break the wall between them to make a path. The stage goes on until we get to a dead-end cell, which has no neighbors to visit. The dead-end cell is deleted from the list. Then we go to a previous cell. The maze is built when the list becomes empty, which means that we already visited all cells of the maze. Our project can solve any kind of maze by two different solve algorithms, BFS and DFS. I would like to show you the difference between these two algorithms and explain you how works each and every one of them. Let's start with the first one, with the BFS. It's called breed first search. It starts as a tree root. It keeps checking the closest neighbors by a priority queue until it reaches the goal. In parallel, it is creating connections and calculating shortest way to the goal. The second one is a DFS. It's a depth first search. It also starts as a tree root. It keeps checking the neighbors as far as it can get on a specific branch. Then it sets new start position as one of the neighbors. In parallel, it's also creating connections and calculating the shortest way to the goal. Okay, now let's start the game. First, we open the instruction file and follow it. We press the first run file in order to create the properties for the game. After pressing it, we see that XML file is created and we edit the file. We can change between the view type by changing the value in the isGUI field. For CLI, we write false. After that, we run the run file to see if the properties are okay. As we can see, the CLI works just perfect. Now let's change the isGUI field to true to enter the GUI. Now we put the run file. Okay, we see the window here. We press the generate button to create a new maze. We put the measures of the maze that we want. Let's put 3, 4, 5 and press generate button. Now the maze is generated and we press play to play the game. We see the Moses character that is on the screen. The goal is to find the path to Israel. You cannot walk through the water, only through sand. We can move the character by using the keyboard arrow buttons and change levels by pressing page up and page down buttons. If we can't pass the game, we push the hint button to get a hint. As you can see on the upper left corner, we see the Moses position all the time, and now it shows us where the goal is. If we can't win the game, we push on solve button and the character start moving automatically to the goal position. See, like this. Yeah, we have Israel state right now. In our game, we used architecture pattern called MVP, which means Model View Presenter. Each layer has its own purpose. View layer interacts with the user and presents the result of the algorithm as a graphic result. Presenter connects between the model and the view layers, and model is responsible for the calculations. The layers are communicating with each other by notifications. The presenter is a kind of observer, and two other layers, model and view, are kind of observables, which send notifications to the observer. In this case, it's the presenter. For example, user sends a command to the view layer. The view notifies the presenter commanding the model to execute the user's command. The model sends notification to the presenter with the wanted data or info, and the presenter commands the view to display it to the user. Thank you for watching. See you next time in our next project.